You're watching Worldwide News. Subscribe for the latest stories from around the world. I don't think people understand just how much EUV changed the game. In 2018, a senior engineer in Silicon Valley stared at his screen, frustrated. His team had hit a wall. They couldn't make microchip circuits any smaller. Then, news arrived. A competitor overseas had built a chip with features so tiny, it seemed impossible. The breakthrough wasn't American. It was a Taiwanese company, using a Dutch machine powered by extreme ultraviolet lithography, EUV. EUV wasn't just another step, it was a leap, unlocking a new era for the tech industry. For the American chip industry, it was a wake-up call. This is the story of EUV. So, what exactly is EUV lithography? Imagine making microchips, like taking a photo, but on a microscopic scale. Chip makers use lithography, shining light through a stencil to project circuit patterns onto silicon. Enter EUV, a new light. Just 13.5 nanometers wide, lets engineers etch features just a few atoms across. The process happens in a vacuum, using ultra-smooth mirrors instead of lenses. EUV is the tool that keeps technology shrinking and our digital world moving forward. In the 1990s, as chip-making tech hit its limits, 3 global teams raced to develop EUV, one in the US, one in Japan, and a small underdog in Europe, led by ASML. The US effort had the biggest names, but lost faith as costs soared and challenges mounted. ASML and its partners refused to quit, pouring billions into research and forging deep partnerships. Their gamble paid off. Europe, not America, created the world's most advanced chip-making tool. By the mid-2010s, US chipmakers had moved on from EUV, betting on clever tweaks to old technology. They used multiple patterning, a complex, costly workaround, to keep shrinking chips. Meanwhile, ASML in Europe quietly solved the hardest problems, generating stable EUV light and perfecting the mirrors. In 2017, ASML shipped its first commercial EUV machines, each the size of a bus, costing over $100 million. The first buyers? TSMC in Taiwan and Samsung in South Korea, not American companies. Suddenly, these firms could make smaller, faster, more efficient chips in a single step. US industry was shocked. The innovators' dilemma had struck. Success with old tech made them blind to the new. The US had invented much of the science behind EUV, but failed to finish the job. The breakthrough came from Europe, and Asia seized the lead. America missed the boat on the most important chip-making technology in a generation. The result? A seismic shift in global tech power. The world's chip-making center had moved. The US was no longer in control. The consequences would ripple across the industry. Let's meet the company at the heart of it all. ASML, once a tiny Dutch underdog, is now the world's only maker of EUV machines. Founded in 1984 in a shed, ASML faced giants like Nikon and Canon. Their secret? Relentless persistence and a culture of collaboration. Martin van den Brink, ASML's CTO, drove the EUV vision, building deep partnerships with suppliers. ASML became a master integrator, sourcing the best components worldwide. They acquired Cymer for light sources, partnered with Zeiss for optics, and managed a global supply chain. This open innovation model set them apart from more secretive American firms. Today, ASML has a monopoly on EUV machines, each with over 100,000 parts, costing nearly $400 million. The company is now a geopolitical linchpin, essential to the digital economy. From a shed to the center of global tech, ASML's rise is a story of vision, partnership, and Dutch persistence. But ASML couldn't have done it alone. Their most crucial partner? Zeiss. Let's see why. ASML's success hinges on its partnership with Carl Zeiss, the German optics master. Zeiss makes the mirrors at the heart of every EUV machine, among the flattest, most reflective surfaces ever made. If a Zeiss mirror were the size of Germany, its biggest bump would be less than 1/10 of a millimeter. EUV light is absorbed by everything, so only perfect mirrors can guide it. The system uses 10 mirrors. Even then, just 2% of the light reaches the wafer. ASML and Zeiss have worked side by side for decades, co-investing and sharing risks. In 2016, ASML bought a major stake in Zeiss's semiconductor division to secure the future of EUV optics. This deep integration let their engineers solve problems together, something US rivals never matched. The ASML-Zeiss alliance was built on trust and a shared vision, not competition. Their collaboration turned an impossible challenge into a world-changing product. This partnership was Europe's secret weapon. It's why EUV succeeded. EUV lithography redrew the global semiconductor map. TSMC and Samsung, first to adopt ASML's machines, gained a huge edge, making chips smaller, faster, and more efficient. US tech giants like Apple and Nvidia now design chips, but must rely on TSMC to manufacture them. The world's most advanced chips are made overseas, in geopolitically sensitive regions. Intel, once the leader, was caught flat-footed and is now playing catch-up, investing billions to retool with EUV. This shift has major geopolitical implications. A single Dutch company builds the machines. A single Taiwanese company makes the chips. Governments worldwide are scrambling to secure their own chip supply. The stakes? Economic power, national security, and the future of technology. The world order has changed, and it all started with EUV. Why does a $400 million machine matter to you? EUV powers the future. Your phone, your computer, your car all depend on chips made with this technology. EUV enables new breakthroughs, true AI, 5G and 6G networks, virtual reality, and more. Without EUV, progress would stall. It's also critical for national security. Advanced defense systems rely on the most powerful chips. That's why governments are investing billions to secure chip manufacturing at home. EUV is the engine driving the next wave of innovation. It keeps Moore's Law alive, letting us tackle humanity's biggest challenges. The future is built on sand, and EUV shapes it. The impact is real, and it touches every part of your life. That's why EUV matters. The story of EUV is a lesson in vision, risk, and the cost of complacency. America, the birthplace of the microchip, missed the most important manufacturing breakthrough of the century, not for lack of talent, but for lack of imagination. While US giants optimized the present, Europe built the future. The result? A strategic vulnerability the US is now racing to fix. Billions are being spent to catch up, and the global tech landscape has shifted. Technological leadership isn't a birthright. It must be earned, again and again. Now the US is all in on EUV, determined not to miss the next breakthrough. The EUV revolution proved that innovation can come from anywhere, and that long-term bets can topple even the biggest incumbents. ASML's rise is a story of determination and vision. For America, it's a wake-up call and a chance for renewal. The challenge now to lead the next great leap in technology. The future belongs to those who see it coming and dare to build it. That's the lesson of EUV.